So this is a lesson on trig equations. We have already dabbled in trig equations in some of the earlier ones, but they were always very simple equations. So in this lesson they're going to gradually get more complicated. So they'll involve a bit more algebra, but at heart they are really just looking for angles within a specific domain. Now, to further complicate or simplify things, depending on how you look at it, these ones are going to be dealing with special angles. And just to remind everybody, very important topic in this is the use of special angles. And these special angles are your 30, your 45, your 60-degree angles, as well as the quadrantals, 0, 90, 180, etc., in degrees or in radian measure. And you need to memorize them. You need to know, for example, if a sine ratio is equal to square root 3 over 2, you need to know that the angle in question is 60 degrees or pi over 3. Anyways, here is our first batch of questions. We want to find all values of theta in the domain 0 to 2 pi. So when you see this domain given in radian measure, we know that it has to be, our answer has to be in rads. And we also know we're looking for angles, so we will be given a method to find the ratios, and from there we find the angles. So here's the first question. 4 sine squared theta minus 1 is equal to 0. So the algebra part of this is going to be isolating your sine squared theta. So you take the 1 over to the right side and divide by 4. I'm going to do this in one step simply because it is a fairly routine problem. Sine squared theta is equal to 1 over 4. And then we need to get the square root. Remember that when these ones are written in that form, you are in fact dealing with an exponent of the entire ratio, sine theta all squared. As well, keep in mind that when you take the square root of something, you need to go both positive and minus. So we'd get plus or minus 1/2 when we take the root of that. The root of 1 is 1, the root of 4 is 2. Now when you're looking for angles, you can always use your calculator. That is, you can go second function sine in either degree or rad mode and get your answer. But because this is a recognizable ratio, you've seen this one before, you shouldn't need to use your calculator. Should also be aware that because it's plus and minus, we're going to be in all quadrants, all 4 quadrants. Sine is positive in 2, sine is negative in 2. And our reference angle, sine is equal to 1/2 at 30 degrees or pi over 6. And for now I'm still going to write both of them out, but I am gradually moving more and more to just radian measure as you get comfortable with these. You can view that on your unit circle, which is a great way to keep track of all these ones. And then I'm going to put up a rough sketch just off in the side. And a 30-degree angle in all 4 quadrants. Just really getting a rough graph for it. And that's actually 30 degrees or pi over 6, pi over 6, pi over 6, pi over 6. And you should by now be getting comfortable with these. So your answer in quadrant 1 is pi over 6. A pi over 6 reference angle in quadrant 2 would give you a rotation angle of 5 pi over 6. In quadrant 3, we have 7 pi over 6. Quadrant 4, we have 11 pi over 6. Now you can get fast at these, but the main thing is that you know where those numbers come from so that you can get them. The speed will build up as you do them. Now that's kind of a mid-level question. Let's take a look at another one that will require more from us. So cos squared theta minus cos theta is equal to 0. We have another quadratic equation. And in order to solve this one, you need to take out a common factor, the largest common factor that you can, and that's going to be cosine theta. Now some people do use a substitution on these, and I will, when I get to the next batch of them, I will myself do that. But because this is a fairly easy one, once you train yourself to identify that it's just really just a polynomial, and that can be simplified by taking out a factor from both terms, you get this, cos theta minus 1. What's interesting about this problem, in my opinion, is that we're dealing with quadrantals. So cosine theta is equal to 0. The other possibility is cosine theta minus 1 is equal to 0. So we set both factors to 0, just like you would a regular simple quadratic. And this is what we get. Both of these will provide solutions, and we treat them the same way, at least for a while. So for cosine theta equal to 1, I'll do this one first. I'll note that cosine is positive in two quadrants, quadrant 1 and quadrant 4. And if you used your calculator, you would actually get a reference angle of 0. And if you took that reference angle of 0 in those two quadrants, you're going to be right there. And that would tell us that theta, in fact, our answer is just equal to 0 rads. Now, you probably didn't need to do that because you'd be thinking, well, all I need to do is take a look at my unit circle and recognize that for quadrantals, cosine theta is equal to 1 right at that point, at 0 rads or 0 degrees. So the unit circle is great for quadrantals. So keep that unit circle in front of you for these questions until you have it more or less internalized. You could also have, because it's a quadrantal, you could have gone directly to your calculator, second cos 1, and you'll get an answer. Now with cosine theta is equal to 0, you could do the same thing, but if you did use your unit circle, you will note that cosine theta is equal to 0 in two places. And I'll go directly to the answer. At 90 degrees, or pi over 2, because x is equal to 0, and also at 3 pi over 2. So this is going to give us our answers. Let's take a look at another one. Now, these are all challenging questions. They really force you to get good at the basics. So the ones in that you get in homework assignments are very, very important to work on. Now this one works kind of the same way. We factor out a cosecant theta, and that will leave us with cosecant, excuse the sloppy writing, that will leave us with cosecant theta plus 1 is equal to 0. Now these are two reciprocal graphs, or functions. But we do the same as before. We set them equal to 0. Cosecant theta equals 0. And cosecant theta plus 1 is equal to 0. So therefore, cosecant theta is equal to -1. Once again, we're going to be in quadrantal territory. I'll deal with the easiest one first, cosecant theta equal to -1. The reciprocal of cosecant is sine. So this is sine theta is equal to -1. Now we have a choice with this one. We could either treat it the traditional method, which is to identify the 4 quadrants we're in, or the 2 quadrants, and this would have to be sine is negative in quadrant 3 and 4. And if you used your calculator, you would actually get a reference angle of 90 if you ignored that negative sign, 90 or pi over 2. So this is the more conservative method. And if you took a reference angle of 90 degrees in quadrants 3 and 4, you'll see that it always, or it will, those two values will meet right there at 90. And 90 down, so that would actually take you to 270 degrees or 3 pi over 2. But as well, you could simply use your unit circle to get you there. Now the other one can be a real problem because we have cosecant theta is equal to 0. We have a reciprocal graph function, and this one gets complicated simply by, if you wrote this as 0 over 1, you'll see why it doesn't work out too well. Because when you take the reciprocal, sine theta is equal to 1 over 0. Now I'm doing this the long method, but you will very quickly work out a quicker method for solving these. So I wrote cosecant as 0 over 1, which is technically correct. Any number can be written over 1. This is an easy way to solve them. So therefore sine theta is 1 over 0. And this doesn't exist. This is undefined. And because it's undefined, 1 over 0, we look for places where sine is undefined. And sine is not undefined at any point in the entire rotation. So sine theta is defined for all real numbers. So therefore, there is no solution for that particular factor. Cosecant theta is never equal to 0. It cannot be equal to 0 simply because sine theta can never be undefined. So this is one where if you tried to put it on your calculator, you'd be shut down as well. It wouldn't give you an answer. Tricky problem. So I'm going to leave with those 3 examples, and there will be more in the next one. So the next batch of lessons is going to be just practice examples of these trig equations. Thank you.